Good morning, namaskara, good afternoon, good evening, wherever you are joining us today. Welcome to Robocorp Product Hour Live. This is our second edition. I have joined from Bangalore, and I have my colleagues from all over the world and the larger community from all over the world joining us today. Thank you so much for joining. We have had the first edition a couple of weeks ago, and we had an overwhelming positive response. And here we are back again with a very interesting topic to make yourself better developer, faster development of your Gen 2 automations with Robocorp on VS Studio. Today, I'm joined with a colleague, a surprise guest who is going to talk to you all in a few minutes from now. A very experienced and senior engineer who likes to code on VS Code, like most of you are. We'll start the day with some quick demo on something like ChatGPT, because everybody speaks about generative AI and ChatGPTs. So probably we are not going to get away with the not being with the hype. I'll start that. At any point in time, if you have any questions, please drop that in your comments. We will definitely have a Q&A session at the end. But if there are any questions in the meanwhile, please drop that on the chat box as well. Once again, welcome to Product Hour Live. Let's go to a quick demo. I hope you can see my screen. Can somebody confirm from the comments if you can see my screen? Cool. Awesome. So this is our developer Slack, and we have a new channel called as Ask Kappa. So what this particular channel does is it automatically answers any questions that you have on Robocorp, any queries that you have. You can ask and get an immediate response. You need not wait for some of us or fellow community to answer. Kappa is trained with all our documentations, blog posts, our portal examples, and it has the ability to answer any of your questions. I think some of you have already tried this, but if anybody who would want to try it out, give me a questions in the chat box, and I will try to ask that question. And let's see if Kappa can give us a good enough answer. Any questions from the participants that you would want to try with Kappa? I will go first. Probably I will ask, how do I click a button on all I need to do is tag Kappa AI. It immediately gives me a note saying that it has taken the question. It will take a few seconds for answering. I see a question from Yogesh. What is locators in Robocorp? Somewhat similar kind of a question. I can try that next. So what Kappa basically does, it tries to understand this question, goes through several thousands of documentations page, and then it would try to give us an answer. Cool. It is already published one. If you can see and read, let me widen this. So to click a button on a web page using Robocorp, you can use click button or click button when visible keywords. Both of them are from RPA browser library, maybe rpa.browser.selenium library. And there is also an example and more references. If you think this answer is helpful, you say it was helpful. Otherwise, downvote it so that it can understand if it was useful. I see a couple of other questions. How to get all data from table HTML to object. Let me try this one last question from one of the participants. How to get all data from a table HTML to object or to any other structure, maybe a list. Okay, let's see if this gets us the answer. About 15 seconds. Now 15 seconds seems longer, but definitely better than waiting for a human to answer. This is definitely faster. Cool. Any other questions in the meanwhile? For you to get this, you can just join our developer Slack, and the name of the channel is Ask Kappa. Maybe I'll remove the banner so that you can see the. This is, yeah. To get all data from an HTML table and convert it into list, you can use beautiful soup library. And this is a further example. Yeah, it lists out the name of the flow in which you have to do logical explanation, and also some code examples that can help. Yeah, looks like a decent answer, and I say thumbs up. Cool. How cool is that? Yeah. I suggest and recommend to get onto the developer Slack. There are multiple channels, multiple product channels where you can ask questions. Robocorp product and engineering team is highly active, and so is the community from across the world. So there is somebody who might have already faced the questions that you want to ask. They will certainly be helpful, and let's build an ecosystem and share the knowledge that we have together. So that's Kappa, and let's get back to the actual topic of the day, which is the VS Code extensions. Okay, so as you are aware of our VS Code extensions, there are two extensions that you would use to build Robocorp automations. One is the robot language framework, and the other one is the robot code. Today we are going to focus a lot more on this particular extension, which gives you the ability to have those widgets and tools that will help you build your robots faster, better, and more efficient. How do we build them? Is with IntelliSense, some code completion. How do you get the documentations? How do you understand the keywords? But also with some of the widgets like the inspector tools, the ability to capture the locators, and also more so the debugging. How do you build the code while you are debugging so that you build quite a robust robot and build it efficiently and fast? I will quickly show you some of the resources that you have that I mentioned. You can create any browser locators or image locators or Windows locators. When you come to the extensions panel here, when you have installed this particular extension, you see all the robots in the given file. You can run a robot or debug the robot directly, or you have the other actions of uploading this given robot to the control room, or open this robot as a flow explorer to visually see what you have built. And some of the other resources panels, which are the widgets like inspector tools, which will help you capture the locators for your various elements that you interact on the UI layer. There is also work items. Locally, you can build work items and run work items without having to go to control room. There is going to be a detailed explanation of this in the later part of the session. But these are the resources that will help you. Finally, you can quickly see what are the connections, the connections to your control room and Vault. And you can toggle between multiple workspaces and multiple dev production test environments with just a click of a button here. Cool. Now let's go look at one of the code and show you my favorite topic. Maybe let's go to a task.robot. Control Shift. Okay, so most of you have gone through the certification courses and you might be familiar with the robot. But what I'm trying to show you here is the ability for it to understand and auto-complete some of the keywords. Let's go to maybe keywords library, maybe another example. Okay, so when I say add submit button, so this is the feature that kind of helps you the most when you are writing your code. It is automatically able to put up all the keywords that are there in the libraries that you have imported, along with the explanation of that particular keyword, what it does, the various params, and an example as well. So this, you need not actually go out of your Visual Studio Code to understand the documentations. While there is a very detailed documentation on robocorp.com/docs, everything is embedded inside the code, and then you can complete that quite easily. I will show you a few more things maybe later, but we have a guest joining us. So let's put him on the stage. He will continue to show some amazing examples and live coding and debugging examples. We have Cosmin, who has joined us from Japan. He's a globetrotter in truest of the sense. He's a senior engineer who builds a lot of useful features for all of you. I am sure you have interacted with some of the great things that he has already built. I will put him on the stage and request him to introduce himself further and take us through the demos. Hey, Cosmin, can you hear us?
Yes, I can hear you well. Hello, everyone. Cosmin here. And thank you, Tejus, for the introduction. Hopefully, you can all hear me well. I'm going to begin with sharing my screen as usual. Okay. I guess you should see it in any minute for now.
Yeah.
So here's a small agenda I'm having for you today. My aim right now in this couple of minutes is maybe to make you unleash the full power of VS Code with our own extension. So you can maybe develop faster, understand a few concepts about logging, debugging, and an interesting concept at the end, like the work items and what are those. But before that, quick intro, continuing about me. My name is Cosmin Poiana. You can find me with the handle CMIN764. Don't ask me about the numbers, they're old. This is the unique handle I'm using for GitHub, LinkedIn, and anything else, social networks, Facebook, Instagram, wherever you want to search there. For work-related matters, you can reach me out at this email address at Robocorp. And speaking about Robocorp, you can find me on the community Slack with the Cosmin/Robocorp username. Joined the company almost 2 years ago, and I'm mainly building solutions for customers and contributing to the library. So that will be like the thing that we'll be using right in VS Code to build robots. That's exposing the keywords. So starting with the first thing here, like what is actually logging, I will show you two things that are really helpful to understand better what happens in a robot when you run it, and after you run it, the terminal and the robot output tabs of VS Code. And this is right here. I'm having a small demo for you. It's called Simple Strings Robot inside a robot called Robocorp Debug. And right here, I'm just having a string that I'm not doing anything fancy with that, just splitting it into individual words and then joining them and then printing them. So as you can see here, there are two kind of loggings that I'm using. First of all, I'm logging to the console, the string that I'm also logging in the normal log. And then I'm replacing a word there in that string, and then I'm logging it again. If I'm running this with the command Shift-P to open the command palette and using the run robot command, or you can go to here, this little monkey head, here our logo, and you will see your bot, and then you can use the run or the debug buttons that you will see later on. Never use the one here on the right because this is coming just from VS Code. The ones here are coming from our extension, and we'll be able to initialize the environment properly. So everything will be just in place, especially on the debug side. So I'm going to just hit run of this. So Command Shift P or Control Shift P on a Windows system, run. You'll see run robot command. And then I'm seeing a lot of tasks here. I'm calling the simple strings one. And what you'll see next, I'll be talking about that later on. It's about choosing a work item. I won't choose any here. So I'm just pressing enter. And my bot runs. So what you will see here right in the terminal is basically the output of the bot, like when you print something. That's why log to console, when I'm printing this console in the string, will be displayed like here, console and my string, which is a concatenation of these words, apple, orange, banana, with a comma in between. Then I'm just replacing the apple with kiwi, and then I'm printing again here on line 16. And as you can see, it's printed down below. This is useful like from some sort of old school, print-based kind of debugging. So you see along the way when you build your bot, like what kind of values you have inside there. And maybe you're putting those for debugging reasons to speed up development in case you see something that's not right there. So this are basically kind of like prints. Then you see the logs. These are displayed here in the robot output. So as long as the robot runs, you will see this appearing one by one, all of the keyword calls, especially these logs, that logs that string in our example. And this is the same and more nicely formatted as if I click here in VS Code, this log HTML link, which opens the log file, explaining to you what happened there in the bot run. If you click this little arrow here, we'll expand everything. The next thing to go here will be to these timestamps. So you have an idea of how much time it took for any of those keywords to run. So if you spot anything that's crazy long, maybe you should investigate that further and see why it takes that much. maybe forgot to sleep inside, maybe the algorithm is not optimal. So these are pretty useful here. And of course, when you have an error, this log will span directly to that error. So you'll see where it comes from. And if that's not sufficient, let's say you want more details, right in the robot YAML file where you configure a bot, you can, for example, write a fancier kind of more custom way of running a task where you specify the shell command. And I'm having here an interesting ltrace command with a parameter which tells me, like, give me the whole log, like with including trace. So if I'm running this again with a trace, I should see my bot run into the same way. Just the only difference that if I'm refreshing the log now, I see a log level trace that I can switch it back to info or then again to trace. This trace, as you can see, shows me a lot more about what's happening inside the bot, including what arguments are received, what it returns. So this is quite useful when you develop the bot, and for security reasons or the usual behavior is actually to just display the info part, because in trace you might see a lot of details that you don't want to see there. So that's basically it. It starts from the terminal and robot output tabs. Then you can serve that log HTML. There are also a couple of handful wrappers over the log, the simple log. One of them is log list, for example, which will help you save some time because it's logging an entire list object. And you don't need to iterate with a for example. So you have a loop where you get every item in a list, and then you print that item in case you want to print an entire list, like nicely formatted. You can just use log list or log dictionary in a similar way for dictionaries. And the logging levels, as you saw, are configured in that robot YAML file. So that's about it with logging. Nothing too crazy here. I'll jump now to the next thing, which is maybe what you're interested mostly into. It's the debugging and how you can gain some speed here when you're developing a bot, not just debugging it. So I'll run the same example again, but this time I'll be putting a few breakpoints. You can do that like right in VS Code by clicking this red dot over here. And I'm purposely putting those over the log to console just to stop the execution here. I'll issue the command palette again with the command or Control Shift B shortcut. And instead of running the bot, I will debug it right now. And I'm gonna run then again the same task called simple strings, in my case over here. And if everything works correctly, the execution should stop at the first breakpoint. And it just stopped. So as you can see now on the left side of VS Code, it just spawned this tab here, this pane here, the debugging one. And if I'm expanding this a little bit, I can see some variables. These are useful, are populated automatically with the variables that you see over here in the code. You can even add watchers. Like I can simply, add in, an expression like, give me the value of this variable called string. Pressing enter, and it tells me like what it contains and how it is. But you can write more complex things like get regexp matches. And what this does, it's a keyword that looks in the string, in my string over here, and tries to find words that ends in one of these two letters, E or I. And in my case, it found apple and orange. As you can see here, both of these two are ending in E. Of course, you can do anything you like here that evaluates. So you can put ifs, you can chain keywords together. You can do a lot of things, so you can watch for the things that are happening. In case you are expecting for a variable to have a value, or for some behavior that you want to see happening in your bot. Because when you have a problem with the bot, in fact, you're expecting for something to happen and that thing doesn't happen, or something else happens additionally or less. So that's the purpose of this whole exercise here, to detect where the problem is or to gain some confidence along the way. Maybe you don't want to write like 500 lines, and then run them and expect for everything to just work. You write a few, you run, you see what's happening so far, then you add a few more, you continue to run. as like, I don't know, in a simple case, maybe you'll be putting some prints and you'll start over again and over again, but that consumes you a lot of time. So it's much more faster to just put a breakpoint, stop at a certain point, execute some commands or watch some variables, and then continue from that point onwards, because you'll be that sure that what you've written and tested here in the debugger will work the same when you copy and paste it back in the robot code, as long as you develop the code. Then you have this, usual debugging commands through which you can step into a function, get outside of it, or continue to the next breakpoint. If I'm using this continue, we'll just continue the execution until the next one. And as you saw immediately on the left, the new values of this string variable and these watchers have changed. Because as you saw on line 15, I was just replacing the word apple with kiwi in my string, in my initial string here. So now I'm having kiwi and orange ending with me and I. I don't have any apple anymore, because you just saw that this string changed. So now I'm very confident that what I've done here actually worked as I expected. So that's how you basically debug something for the most of the simplest scenarios. And then I hit continue, the debugger exits, execution ended. I've got now the logs, everything passed. And you don't need actually to put breakpoints. It's not mandatory. The execution will stop even if an error happens, or there's an error raised somewhere, and will break the execution, will stop the execution no matter what there. And that's how you can do that. Now, a more interesting thing about that, the most important thing about that actually is, if I'm running the debugger again with this one, is the fact that you can also use an interactive console to test out code, robot framework code, right in the console. So you can test things out. If you go here to the debug console, you can literally copy and paste statements in a robot framework, hit enter, and like this replace, for example, and you should see what's happening. And let's say if I'm putting something wrong here, will error. So like this, you can test out, like right in the middle of the execution, things that you want to implement further in your bot. You test them, you play with them, you see the behavior. Once you like that and you accept it and you feel that it's doing what it should be doing, you can just copy and paste the thing that is working from here back in the robot code. Then you'll be very, very sure that that thing is working as expected. At the same time, you can inspect variables, because you've got this string that's also working, and you can import libraries, maybe lots of things with this debugger console. I'll be stopping the execution and going to the next example, because this is not actually like a real life case scenario, but there is one that might work better for you. So I've got another task called fill a form, and I separated this in individual files to make life easier here on reading them. And this one is a little bit closer to what you usually expect with browser automation, for example. As you can see, I'm importing the RPE browser Selenium library. And with that, I'm opening a browser, going to a page that contains a form, and I'm trying to select the checkbox that I'll be finding there and do some other things you'll see up next. I'll be just putting a breakpoint here, because this seems like a little bit more complex. And I'll be honest with you, when I was developing this example, I really needed this breakpoint before writing this code over here. I haven't just written it from top of my head and then it worked flawlessly. No, that will never happen. All the time you need to test things out, see how they are working, because they might not work as you expect from the beginning. So in this scenario, I'll be hitting the command palette again, Command Shift P or Control Shift P, debug robot, but this time I'll choose the fill a form task. So I'll be running this. No work items again, because I haven't reached that step yet. So what this actually does now, it opens my browser, as you see this little Chrome window here, and it magically appeared on my screen. It went to that page I was going to, this form texting. And I also selected the checkbox, meanwhile, named box. And then I'm checking with this keyword, checkbox should be selected. These are all coming from the Selenium library. And as you can see, this is the form I was talking about. The checkbox is checked. And it stopped like right here because I'm not very sure what would be happening next, or maybe I need some extra help. You can use the inspector, our inspector in VS Code, but that's like a whole different discussion. Or you can just, issue the developer tools with Command-Shift-C. I'll be pressing that now. This helps me inspect the elements here in the page. And also, targeting them. Like, I'm interested in this text area. Let's say I want to automate this or insert something inside. Once I click that, I can see here on the right side that there is a text area. That's not too useful for me right now, but I see a name comments. So I'm not sure if this locator actually works. I saw some of you were asking for locators. So let's see if that really works. And if I'm going to the docs, and these are very useful when you're not aware of the surroundings of the libraries, you can search for a library like this on the left side. You can go into the one of interest, Selenium. Let's say I want to input something, and it's about text. I can just write text, maybe input, or just input. Okay, I see there is a keyword for that. That's input text. That simply input some text in an element if that supports it. So I'm getting back to my magic debug console over here. That's my friend today. And I'm literally going to write input text. And then I'm putting comments as a locator. I'm not sure if that works. I'm trying that. And let's say I'm writing here Robocorp is awesome. So I hope it's worked. Getting back to my browser. And it actually worked. As you can see now, the text is here. So right now, you know exactly that this command works. You're very sure. You don't need to, trial and error that, like putting that in the bot, running the bot, going through the login session, maybe you have any, surfing through the pages, going through the entire process, and then you will hit this. And let's say you got the locator wrong and it doesn't work. What do you do then? You restart, then again the process after changing something, and you're waiting, fingers crossed, maybe this time will work. You cannot do that over and over again, because instead of a few minutes, like it took me right now here, it might take you like hours to, get it right. So the aim here is to improve the speed. And what I'm doing in my code, I'm using the same locator. I'm also prefixing it with a name because I'm telling explicitly that I'm looking for a name equaling to comments, and then I'm retrieving that web element, waiting for it to get visible. I'm doing some checks. The initial check is to see if there's some text inside, like literally these 2 words. Then I'm changing it with another text, and I'm checking it again to see if that works. I can put maybe a breakpoint again here. Out of the blue, I'll continue the execution. Okay, of course, it gave me an error because it was looking for some text, but it has now Robocorp. It's awesome. And that was like the initial check. It's normal to happen. I'll continue it again. And it stopped. Now, if I'm running this bot without debugging mode, like literally running the robot, fill a form, you should see now this entire behavior I explained to you going like fast, one by one, statement after statement. So the browser opens, going to the page, clicking that checkbox, submitting the form, and it just finished and closed the window so fast that we didn't even have the time to see that the form was successfully submitted, and then the page was checked to see if it contains this another word coming from this another text submitted to the form. If I want to check that, I can run it again, bar robot, fill a form. Who knows? Maybe I've got a bug here in the bot and it's not checking for the right thing. The solution for you, put a breakpoint, you run the debugger, and it will stop execution right at that breakpoint. If I'm getting back into my browser, I can see now the result of the submitted form. And there is actually this another text that was completed by me right in the page source. And just for testing purposes, let's say I'm copy and pasting this instruction here, going to my debug console and pasting it here to check how it works. It works. And who knows, maybe that will work all the time. Let's change something here, like putting an X. I can see immediately that this jumped out of the blue here in my page, and that usually means that something bad happened. So page should have contained text another X, but it did not. So I'm now, trusting my code. I know very well because I just tested these things here in the debug console. I'm now, confident enough to maybe push this to production, and I'm happy with the result. So I can just stop the debugger, and this is like closer to what you will encounter when, for example, you develop a bot that's automating the browser, but you can do the same for anything else, like automating desktop applications or working with documents, or it works in all the cases. Now, getting back to my slides over here, the next thing is not about debugging anymore. It's about the work items, the concept that also just showed to you quickly in the introduction. I've got for you another task here called Excel to PDF. This is all about what are work items, creating one through the VS Code extension, and even creating an output one through the bot so we can use it further. You can see these work items as like a pipeline. Like you have a pipeline where there's a package coming in. Your bot processes it, and then maybe it produces an output that becomes an input for the next bot, which may produce an output or not. That becomes an input for the next one, and so on and so forth. These are like small packages with data. In reality, they are just JSON structures containing data that you can input, including files. And luckily, you don't need to create such kind of stuff like from scratch. If you go to, if I'm going now to my bot, which is called Excel to PDF, and by the way, don't get intimidated about so many lines over here. What you have to see here is that I'm having two tasks, Excel to PDF, which simply gets an input, which is an Excel file, gets some information out of it, like a table, and then outputs a PDF file with that information as a report, for example. You'll see that later on. And then in the next task, optionally, if I want to, I'm getting that previously obtained PDF file here at the previous task. I'm just opening it for display purposes, nothing more. And like I said, this is based on work items. That's why I imported the Robocorp work items library. And in order to create at least one work item, because I have none at the beginning, I'll be using the extension again. You will see here a tab a pane called resources. We've got some locators. We also got work items. And there are the input ones and the output ones. There is no output at the moment, but there is an input. I created this like right before the demo through the extension by clicking this plus button. You can give it a name. I'm just making one out of the blue for testing purposes. And immediately as I hit enter, I'm seeing this work items JSON file, which gets here discoverable by its name. I just enter it, called test. And I see a payload and files. Payload is like a key value kind of structure. We've got key on the left and the value on the right side, exactly as, for example, environment variables or anything else where you can retrieve the value by a key. And I also got some files. This is like a placeholder. Of course, you can remove and you won't have any files, or you can add as many as you wish. And I've got already a one already prepared for you called robot parts. And if I'm opening this, as you can see, there's a test message. I'm not going to use that. And there's also files section where we've got this robot parts Excel file, which also points to itself. And that's like, if I'm retrieving this file in my bot, it will look into this path, which can vary. And we'll retrieve that file and it will give it to me so I can do, further processing over. And now if I'm going into my bot again to see how that works, as you saw, there is this dev data structure. Here is where these work items are placed. As you can see now into this small pop-up that appeared, there's dev data / work item C and robot parts and work item JSON file. And I've got here a robot parts Excel file. You can see it here right now. Here is inside of this work item. And its structure looks like this. It's basically a small table with some heads, bodies, and legs, like robot parts, and the number of them. And the task here in my robot is just trying to, sum up all of them, like bring me the total of all the heads, all the bodies, all the legs, and make a total out of those, nicely displayed in a report file. So let's see how that goes. Going back to my robot, running the first task over here, Excel to PDF. I'm running the bot, not debugging it anymore. And now I'll be running it with a work item because I need that input Excel file I just showed you, because I'm pulling that, I'm processing that, getting the table out, and then obtaining a PDF with the information from that Excel file. Running this will go like this. Okay, everything passed. Let's look at the logs just to make sure expanding all. I'm seeing now that I'm opening that workbook. I'm reading a table inside of it. I'm creating a dictionary with all the parts summed up nicely. And then I'm even creating a PDF file with a lot of info and debugging messages. You can hide those anyway. And then optionally, you don't need to do that, but I'm creating also an output item with that PDF report that goes here into this invoice PDF file. So you just saw some logs about running, nothing interesting. But if you look here on the left side, you should now see like a items out structure, which contains that invoice PDF file I was talking about. And that's easily discoverable here through the Robocorp code extension. When you go back to the work items, you will see that there is a run. And if you click that, you will see the structure inside. So you've got the confirmation that now you've got an output item that contains that PDF I just created. But what do you do with this PDF next? Like, what's useful about that? Well, imagine this as a process that has two steps. The first step, ingest some information and outputs some other kind of information. And then that output from here can become input to the next task, to the next step in your process. And you can chain as many tasks as you want like that, even in control room when you'll be deploying this bot later on to production. So what I'm doing in this one, I'm just retrieving that invoice PDF file. I'm just opening it. So I'll be running the bot again, but this time I'll be running the other task called Open Invoice PDF. And once I'm running this, I won't pick for it, then again, the work item I picked for the last task. I'm picking now this run one, which is the output created from the first run. That will become as an input for this new task I'm running here, Open Invoice PDF. And once I'm running this, voila, I'm just seeing now this PDF file with all the heads summed up, all the bodies, all the legs, as a nice report of summing up and making a total of all the robot parts in that previously inputted Excel file. And I can just close this, and I just have a proof that this entire bot works. So this is what our work items, meant for, to have a way of inputting data and creating outputs that might be input for other processes or other tasks in your own process as steps. And this way you can, process a lot of things like that. And this is a nice way, convenient way of simulating what happens in control room. So you have an idea of how the bot will act and react during the local development before testing it into production or in a test workspace in the cloud. So I've got two main takeaways for you. First of all, VS Code is very powerful for you, especially using that interactive console, through our extension called Robocorp, because it gives you, this ability to develop faster robots and test, debug, and develop at the same time in one go without necessarily doing lots of trial and errors that will, consume your time. And the other thing is this nice concept called work items that can be managed right inside from our extension, from the local point of view. So you don't need to push your bots to the cloud and test them out there. You will have the same feeling simulated locally, and you can use them for inputting various pieces of information that you want to process in your bots. And of course, you can find all the code and the slides and all these fancy links over here into our repository. It's public here, the Robocorp debug demo in my account for now. And there's also a nice link at the end called features, where you can click over and you'll see, in detail what you can do with our extension right in our documentation part of our website. And hopefully we can have the last 10 minutes for some Q&A. And happy to respond. Thank you for watching.
Thanks so much, Cosmin, for such an insightful session. Understanding how to debug will definitely help us not only speed the development but also build bots reliable. I think the problem with Gen 1 RPA tools have been that we build bots which are quite prone for breaking, and it's not reliable. If we build resilient bots right from the beginning, and also we're all developers, RPA developers are lucky and happy that they are able to come back on coding languages and build more resilient, flexible robots. So thanks for all those insightful topics that you have covered today. I have a few questions already on the comments, and I request you all to pose us more questions. But Cosmin, we'll start with something that you talked about towards the end.
Mm-hmm.
So we have Alok who has asked this question: how do we get Q report in Robocorp? Q, as he would be mentioning, will be something related to the work item in itself. So how do they see what items have been completed, which one are errored out? So if you could tell us a bit more about how can they get these reports?
Well, in control room, if you go to the cloud version, you've got there a nice UI where you can see like all the inputs that are in the queue, like the active step runs and what failed, what not. Even the error are reported ultimately there, and you can release such items. You can find more in our documentation, where if you're not happy with processing one, you can release it, and you will specify an error if it's a business or application error. We've got these two types of errors, where application means something that happened, in your app, might be retried, might work the second time, but business is like the data is not good. If you retry that, no matter how many times you retry that, it shouldn't work, and the execution should stop. So there's a lot of support out there, but getting back locally through VS Code and testing these things out locally, We usually use like a helper, which is called like for like a for each helper that takes every input work item and process that ultimately for you by calling a keyword over. You will see that like right in the logs if something bad happens. And the queue here is not like displayed, like in a way like control room does, like what failed, what not. You cannot do parallelization here, which is quite a powerful feature that our orchestrator supports. But it simulates as much as possible the way you would see these items processed. So you can maybe run with different input items, or you can chain them as a list of this kind of structures that you saw. So maybe you want to try with something different, or you just want to have like a big list with multiple items. You want to get them one by one, process them, and see what happens. But if one fails, you will see the failure in the log, and nothing more. It's like a fast fail, and then you'll go there and treat that and proceed further. So the things are quite simple when you're doing that locally. If that answers like your question.
Yeah, it does certainly. So Alok, I hope I answered it on behalf of you. Please, you could go back to control room. When you run a couple of these iterations, you will be able to find the status of at each item level. You could also, in some cases, if there is a business application exception that happened because the application was not available, maybe there was an internet connection issue or something else,
Yes.
you could also retry at that particular item, just that particular item one more time. If it's a business exception, you could actually try to change the data. Say, for example, there was a spelling error or any other error that the human officer could change, and then you make the modification to that particular item, save that, and retry that particular item in case of business exceptions as well. So those options are available, and I hope you get some time to explore those activities. But certainly a very good question related to work items. We have yeah.
I was going to say that we also have an extensive API for that. So you can inspect yourself through our library or calling the API directly, all the items, their content, their status. You can start new processes with them. So we are very, very flexible out there in terms of reporting and managing those, even ultimately through automation. Yeah.
Cool. This is not more of a question, but quite a good feedback. Plus, the feature of work items, it's not only for dividing the bots, but also it helps you run your automations in parallel. So when you have a specific task that needs to be done for a huge volume of workload, you can put into multiple bots using the work item. So thanks so much, Vinicius, for that comment, which is quite useful to know as well. Another question. How to make good documentation for our robot? That's
a good one.
It's a really good one, because it does not stop at building good robots. How do you actually document it well, so that robots are also another software program. It's not magic, how it is probably treated in many other places. So it is essential that it goes through changes, it goes through maintenance, it goes through updates. So how do we make good documentations, Cosmin?
Yeah, I will start first with the actual code itself. This starts from the root and also applies like the comments. A code with too many comments is not a good code. The code should be self-explanatory. Because most of the times, your maintainers will just go into the definitions, will just read code more than docs. They want to see what's happening there. Why is something not working? Nobody has the time just read tons of documentation to find out that there's a bug somewhere. And well, it's a good habit, but nobody does that. So it starts with the code itself. It should be robust, self-explanatory, well-maintained. Keep in mind a few principles like do not repeat yourself, keep it things simple, and you ain't gonna need that. Don't over-engineer your solution. Once that's done, then we have some interesting keywords in Robot Framework called documentation. You saw them even at keyword and task level, and even at robot level, like right at the beginning of the bot code. Use those to explain briefly like what the task or the keyword or the bot does, and then further, like we've done with our own library, in case you're building your own libraries or extending ours, make sure you document your methods, which are basically is just Python code that will behave as keywords in Robot Framework. Because you might write your bot not just in Robot Framework, it works the same if you write it in pure Python. The keywords are there as well. So make sure you've got doc strings there, and then at the end, in case you publish that somewhere, you've got a process in place that generates some lib specs or outputs some docs by analyzing that code that can be rendered nicely, like we've done it with our library in our docs side. We don't like write those manually. We have a process in place that just picks and collects all the type annotations from our Python code and all the examples that we've got in the doc strings and renders them nicely into those docs that you see on our documentation website. So yeah, start with the code, continue with the doc strings, and in the end, make sure you somehow render those nicely somewhere where they can be easily searched for.
Cool. Thanks for answering that. I think there is no one single framework for this, but the tags like documentation, keywords will help you give it a structure, and also it is passed all the way through the runtime as well. You can see some of these documentations also appearing in your runtime logs on control room. So it gives you not only dev time help, but also when you are debugging in the production, when you are auditing through the production, it also gives you enough understanding and structure of your robots. I'll take the last question because I know we are all almost exceeding the time, but I think one last question for you, Cosmin. Could work items be used to set up and test business edge cases, or do we prefer some other methods?
Mm-hmm.
There are some extremely rare scenarios. Should we use work items, or should we do something else?
Mm-hmm. Yeah, I guess it depends a lot on how do you apply the usage of this kind of work items. Usually I saw customers creating those just to test different scenarios. So it's obvious that among those different scenarios of different kind of inputs, like different sort of documents coming in that you want to process, or other blobs of data, like I don't know, IDs in a database through which you will use to extract some information and play with that later on in your bot without containing the entire data in that work item. It's obvious that among those you can also slip in things that will try to make your bot break, or will expose something that's odd about what you usually expect to process, or an edge case, or I don't know. We even have got examples, even our courses, of invalid data coming in through the work items, and you should be prepared for that by detecting that and releasing the item as failed with a proper error message and type. So definitely that's a good option to use work items for such scenarios. The possibilities are unlimited here, because the work item is just a piece of information where you can pack up nicely data, including files. And then it's about your choice what you do with that in the bot. So yeah, definitely wherever that there's something that sticks to data or information that you use as input, including edge cases for, I don't know, such kind of business edge cases, that might work, I guess, if that answers it.
In fact, you would want to test them in multiple scenarios, with good data and with edge cases together multiple times, between multiple runs. So if they use it for with work items, they can run it multiple times, and then different types of inputs can be provided as output, and those output can be taken by some other step, and regressively test that. So yeah, I think it's a good scenario as well. Cool. I think that's it. Thanks so much, Cosmin, for joining. I know it's very late. What is it? Is it 11 p.m. where you are currently?
Well, it's already Thursday for me, so I just passed through midnight, but it's like I'm all hyped here, so it doesn't feel like that. So I'm all good.
So sweet of you to join. Thanks so much. Really appreciate
your
time.
Thank you.
See you soon.
Of course.
And thank you all for joining us live today. This is the second edition. We will definitely follow up with more these topics. If you have any suggestions, feedback, do let us know. I will send out an email with the link to this recording, as well as the presentation that we had built today, and all the codes that Cosmin used during the demo. That will also be available on the GitHub repository, for which I will share the link. I will send you also a feedback form to share your feedback, suggestions, and some of the topics that you would want to discuss next time. We will bring loads and loads of demos and exciting recordings for you, for the topics that you should that you choose. Until we see you next time, thank you. Take care. Have a fabulous day, evening, night, wherever you are. See you soon. Bye-bye.